Okay, this is the 2020 paper, question 8 from your paper 1. Okay, this is a remainder theorem as well as a comparing coefficient question, right? So you can see the remainder for when this is divided by x minus 2 is the same as the remainder when it is divided by x plus 1. So here we can easily come up with our remainder theorem format, where this is equals to x minus 2 quotient plus remainder, right? So this is our dividend, or what we want to divide by, is equals to our divisor multiplied by our quotient plus our remainder. So if there is no remainder, everything will be in our quotient. Okay, that's your factor theorem. But in this case, we have both have remainder. And just so happen that these remainders are the same, right? So here, very easily, you can actually see that to find your r for the very first one, we can actually sub in a very suitable value of x to be 2. Right? Because once we sub in x equals to 2, we get rid of the entire quotient, which is great because we don't know what the quotient is. When we sub in x equals to 2, we get 8 plus 2a is equals to 0 plus r. Or in other words, thus equals to r. This is our very first equation that we have. Afterwards, we also have another relationship where they tell you that this remainder is the same when it is divided by x plus 1. So again, we can come up with our dividend is equals to our divisor times quotient. In this case, I'm going to name the quotient differently, px, plus our remainder, where our remainder is the same, so I'm going to write it in the same color, equals to, plus r. And here again, we can sub in suitable value of x to get rid of our quotient that we don't know about. And this suitable value of x that we're going to sub in is x equals to -1, because gets rid of this whole term. And when we sub in x equals to -1, right, on this side, we're just going to have -1 cubed plus a times -1 is equals to, this term becomes 0, so it's just equals to my r. Simplify this equation, we'll get r to be equals to our -1 minus a. This is our second equation. And all we do here is simultaneous equation. We're just going to equate both of our equations together. Since they are already both equals to r, I'm just going to equate our r's together. And from here, you can simplify to give you your value of a. I move this over, I get 3a. I move the 8 over, I get -9. My a would be equals to -3, and this would be my answer. Okay. Okay. Then the next part B, they tell you solve the equation of this, expressing your answers, expressing non-integer root in surds form. Okay, let's first check if these two parts are related. Well, they're not related, so you will do this on your own. First thing to always check is there any factors? Are there any factors to this cubic equation? Well, you can first press your calculator to give you any factors that you have, right? So in your calculator, make sure you write in your cube root rather than your square root that you're used to. Your cubic equation rather than your quadratic equation that you are used to. So just key in all our values, our a as 1, b as -2, c as -4, and d as 3. And then you just need to find some factors, right? Of which we can say that suitable value of x is that x will equals to 3, right? When you write x equals to 3, when your calculator, they give you 3 different answers. One of it is x equals to 3. And the other 2 are decimals on your calculator, right? X equals to 3 is basically one of the solutions to which it equals to 0, right? So we will sub it in 3 cubed minus 2, 3 square plus, minus 4 times 3 plus 3. This will give us 27 minus 18 minus 12 plus 3. And this indeed gives us 0. And from here, we can then conclude, therefore, x minus 3 is a factor of this cubic equation. And once we have established this, we would then use our comparing coefficients method, right? Of which our left-hand side would just be our cubic equation. So this is our comparing coefficients. And this method is very, very useful. Make sure you know it, familiarize it, because you use it in other topics like binomial as well. Okay, so we're comparing coefficients. We can say that this whole thing is also equals to x minus 3, which we found that to be a factor, multiplied by our ax squared plus bx plus c, because we know that there's another quadratic equation over here. But if you already know that, you also can predict that a is actually just equals to 1, right? Because we can see our cubic coefficient is just 1 over here. So here is just 1, and we don't have another unknown that we need to solve for. We just have x squared plus bx plus c. Over here, you need to start comparing your coefficients. We can first start with our x squared. Well, x squared, we have x times bx, we get bx squared on the on the right hand side, and on our left hand side we have just negative 2x squared. And since I'm only comparing the coefficients, I can just get rid of the x squared, I can just get rid of the x squared. All I have here is just b lah. Similarly, we are also finding out our second x squared, which is actually just minus 3, right? Because it's minus 3x squared, but again, I'm only comparing coefficients, so it's just minus 3. And here we already are able to find out what our b value is, right? Our b value is essentially equals to negative 2 plus 3, b is equals to 1. This is one of our solutions to our quadratic equation later on. Similarly, we can also compare our negative 4 value over here, or even better, you can compare our 3 value even here. This is even faster, right? Because 3 is basically the same as negative 3 times c, because this is the only values that when you multiply, you get numbers. So 3 is equals to negative 3c, and c is equals to negative 1. And once you find that c equals to negative 1, we can then rewrite this whole our cubic equation to give us that this whole thing is equals to x minus 3 x squared plus x minus 1. And take note that the question already preempt you that you are supposed to give your answers in non-integers roots in surds forms. Means we're actually just solving for this to be equals to 0, of which we can say that x minus 3 is equals to 0, or that of x squared plus x minus 1 equals to 0. If we were to solve this on your calculator, you're going to get decimals, which should prompt you that you need to use your x equals to minus b plus minus square root b squared minus 4ac over 2a formula from your EMath. Okay, in EMath, this formula is given to you at the very front over here. So in case you don't remember or you want to double check, the formula is given to you over here. So make sure you check it. Okay, so do utilize that to solve for our quadratic equation over here, right? And our other solution here is very easy lah, x equals to 3. Right? So when you simplify the other one, you should get x equals to minus 1 plus minus square root b is again just 1 minus 4 times 1 times c is negative 1. So make sure you write the negative in there. Over 2a. 2a is just 1, so it's just times 2. So at the denominator, it's just 2. Simplify this, because they want it in terms of surds form, we get it to be negative 1 plus minus square root. Inside, you're going to get square root 5, right? Because minus 1, right? 1 minus 4 times negative 1, which is plus 4, which you're going to get square root 5 over 2. And this is your other answer for this question. In other words, you will need to represent it to be x equals to 3, x equals to negative 1 plus root 5 over 2, x equals to negative 1 minus root 5 over 2. Sorry, in between each of these is or. Okay, so this is your final answer for this question. Okay, so just a very quick recap on both parts. First part is just your remainder theorem. Make sure you're familiar with your remainder theorem, right? Make sure you know how to come up with these equations so that you are able to manipulate them and simplify them to get your simultaneous equations, and then afterwards you are able to solve. And this part just tests you on your factor theorem, right? Finding suitable values to substitute in. And then second part is more on your comparing coefficients, which is a very important technique in A-math. And lastly, to recognize this search form, just make sure that you know you're supposed to solve your quadratic equation using your quadratic formula.